So let's have a look at where we're talking about area, volume, I should say. So volume really equals the area of a cross section multiplied by the height. And the height is perpendicular to the area of the cross section.
I don't know. I'm not the one in your exam. It's someone else's exam.
All right. So what I mean by that is, if you have a sponge, for example, you know when you go wash your parents' car because you guys are so nice and you go wash it, and if I told you that the area of this equals, let's say, 50 centimeters squared. Now, if that is a cross section, it means that the shape of this area will be the same all the way through, perpendicular to that. So if you look at a sponge is, because if you've ever washed your parents' car, you'll notice that was a pretty bad shape, that one. You'll notice that if I cut it any dimension along this plane, it's going to have the same area. So if this was 10 centimeters tall, well, I could actually put 50 centimeter blocks here and I could fit 10 centimeters deep. So on the first centimeter, this would cover 50 square centimeters, right? And then, the next centimeter would cover, like, that would be a total of 100, and then 200. So what we can actually do is we can do the volume equals the area of the cross section, which is 50 centimeters squared, by the area that's perpendicular to the height. So it has to be at a right angle. It has to be perpendicular, times by 10 centimeters. And that equals 500, because what you're really trying to do is you're trying to keep 500 cubic centimeters. You're trying to actually figure out how much volume there is. And this is like a 3D space, and we define those by 1. And all our formulas come from that. So what do I mean by all our formulas come from that? Well, I'm going to quickly take a snapshot of this this rectangular prism here and just show you a little bit what I mean a bit further and unpack that. So obviously, if you look at the very first one, and most of you would know how to calculate the volumes of a rectangular prism. If you don't know, you obviously haven't been awake in class. But really, this one that's 2 centimeters, by the way. So if you think about it, well, if you go length by width, by depth, or by height, that's the volume of it. If you do length by width, let's just say this is our length and our width. So the first thing you're doing is you're going length, area volume equals 2 by 3. And if we actually think about it, it's actually 2 centimeters by 3 centimeters, which gives you centimeters squared, right, by the height. So this is actually giving you the area of this when you go 2 by 3, right, which gives you 6 centimeters squared. Then you're going to times it by the height, because we're actually going to start calculating, and that's the cross section, because notice there's a rectangle all the way through there. So then you're going to go, well, volume equals 6 centimeters squared, which is the area of my cross section, by 4 centimeters. Now you might be thinking, but Mr. Rainbow, you could actually use this. You could do 2 by 4, which is correct. You could do a 2 by 4 first. So you could have gone volume equals 2 by 4 by the height, and that would give you 8 centimeters squared. And then your height would be 3. Well, that's correct, because this rectangular cross section is the same way perpendicular all the way through it. So you could do that, which again is 24 centimeters squared. Or you might have been thinking, hey, Mr. Rainbow, I can think of another way to do this. I could have taken the top, right? When you could have said, well, the volume actually equals 3 by 4 centimeters by the height, where the height would actually be going downwards. So what you've done here is you've found the surface area of the top here, which is 12 centimeters squared, and then you're going to 2 centimeters deep, but that's the cross section, because this cross section, if I go this way, notice it's the same shape all the way through that 2 centimeters. 0 to 5, if you guys can just tell me if you understand what I mean by this, like the cross section. So the cross section needs to be the same all the way through the shape. You can just give me your comments in your side. That would be absolutely fantastic, please. 0 to 5, how you guys are going, just to see if you're getting that or not. So that's where volume really comes from. We're talking about these cube units, okay? If you think about how we convert it, it's pretty much because you've got 3 dimensions in there. We'll look at converting later, but it's exactly the same way we convert. So to go from kilometers to meters, you're just going to times by 1,000. But because we're doing it with volume, we're going to put 1,000 to the power 3. If you're going from meters to centimeters, you normally times by 100. You're just going to convert using 100 to the power of 3. So this concept here of a cross-section is really important. So if you notice this picture here, this cross-section, you couldn't take the cross-section of this side panel because that changes the thickness throughout that. You can't actually do that. So we'll start looking at why these formulas are the way they are. So again, here we're finding the cross-section, times the height. That's what we're doing. So the triangular prism is a really, really cool formula. So obviously, if we don't understand this area of cross-section multiplied by the height, you're not going to understand any of the formulas because really what we're trying to do is just build cubic units, right? And the only way to do that is have a consistent cross-section moving all the way through. So if we look at this triangular prism, let's just do something incorrect here. If you try to calculate the area of this side length, okay, so this is a triangular prism. Now I just want to get you a bit of an idea of what's happening, with this cross section. Now, if you said, oh, let's just calculate this area, right? And let's just say that area was 50 centimeters squared. And then you try to times it by, this height perpendicular. And let's say that's 5. And you might say, hey, it's 50 centimeters squared by 5, which is 250 centimeters cubed. Now, you might think you're right, but actually you're not. Because what you've done here is, if you think about this cross-section, at the very first part, if we just looked at it from this point of view, like looking down onto it, the thickness would be that much. But then as you get a bit halfway through, it's going to get narrower, right? So your cubes, you're not stacking on top of it, and that's going to get narrower again. Until you get right to the end, it's just going to be like a thin line. So you can't go 50 by this because you're not, if you did that, you would actually be making a rectangular prism, right? So you'd actually be calculating a shape. If you did that, what we did there, just say that's the 50, it would just be a, it would be a rectangle, right? It would be a rectangular prism, like so. So hopefully you get an idea if that's what you'd do if you did that. So how do we calculate this? Well, if you think about the shape that has a consistent cross-section, that's why we call it a cross-section. And that's what you really got to know. You got to understand the cross-section is the same shape all the way through if you push it that way. So if I pushed this face all the way through perpendicular, it would be exactly the same dimensions, this face, the area of it, and it would fit perfectly through. So I can take the area of this and multiply it by the height. Hence the volume of this equals the area of the triangle, which is half base times height, which we already know, multiplied by the height. So now we can calculate any volume. So what's the volume of a cylinder? Well, a cylinder, where's the cross-section of that? I mean, you can't kind of take the cross-section of, you can't take the cross-section, on the side, because if you look at the side again, it would start off really small, it would get wider through the middle, until you get to here, and then it would start to get smaller again if you went through that way. But you could take the cross-section of the circle, because that's going to be the same all the way through, right? So what's the area of a circle? The area of a circle is pi r squared, and then you just times it by its height. So the volume for this is pi r squared times height. So really, we can do that for any shape. I mean, I could give you guys, a trapezium. So you're going to use the trapezium formula, which is the area for that is half of a plus b times by, I'm going to call that the height. Let's call this c, which is the height of this shape. Okay, because that's going to give you the square. And then you would then take, actually, let's call it height. Let's call that h online. And then you'd multiply all of that by the length of this thing. Now that is only consistent if this shape and its cross-section is the same all the way through, which you hope it would be. So I'm hoping that makes a bit of sense for you guys. So you'd figure out this area, and then you multiply it by there. Now there was a Year 12 exam in further mass. And students really struggled with it because they didn't understand this concept. And it was actually a concept about a hose. So there's this hose, that goes all the way along. And this hose is 50 meters long. And the question was, what is the volume of this hose, right? And they had this coming out here, and there's a little cross section here. And then it showed you a bit of a magnified area of the hose. And the hose looked like this, okay? So it said, what is the volume of this hose? If the hose is 50 meters long, right? And this hose is this, and the wall of the hose is 2 millimeters thick. And I think the diameter of the outer side of the hose was 10. So this was 10 millimeters. So the question was, what's the volume of it in liters? Okay. Well, first of all, we've got to understand that really, what is this? Well, where the water can sit is in here. So let's just take that circle out and figure out the measurements. Well, if that's 2, that means it would be 2 over here. That means you'd be left with 6 in the middle, right? Because it's 4 and 4 is taken here. So that means the radius of it would be 3 millimeters. Okay, and it's 50 meters long. So that would be the cross section going 50 meters all the way through the hose. So all we need to do now is figure out what this is, but we're going to figure out in centimeters, because if we change everything to centimeters, then we can figure out centimeters cubed. And 1 centimeter cubed equals 1 milliliter, or 1,000 centimeters cubed equals 1 liter. So what we really did is we know that this is 0.3 centimeters, right? And to figure out the area of that, it's going to be 0.3, which is the radius. And remember, the area equals pi r squared. So that's going to tell me that. So 0.3 squared is 0.09. That's the area of it, times by 50 meters. Now, 50 meters in terms of centimeters is that long, right? So that would be your answer for it. So you just jump on your calculator, and that would tell you what it is in terms of centimeters cubed, I should say. So shift pi times 5,000. So we have that many centimeters. So the area, the volume of it, that's not the area. That's actually the area of that one is that. This is the volume of it, I should say. So the volume of it equals 1413.7 centimeters cubed. Now we know in liters, there's 1,000 centimeters cubed in a liter, because a liter is actually defined as a 10 by 10 by 10 by 10 centimeter cubed, believe it or not. So it's 1,000 centimeter cubes would fit in there. And that's what they decided what a liter was. So the volume in terms of liters is 1.4137 liters. And that's the year 12 type of question. So what I really want to highlight with that is volume, and what we do is the really important concept is this. The volume is the area of the cross section. We've already done area. And you've got to understand that cross section needs to be the same, consistently perpendicular through that height. If it is, you can just take the area of that and times it by the height, and it's done. 0 to 5 about how well you feel about you've understood that concept of area times perpendicular height will give you the volume of something. If you guys can please just give me a bit of feedback on the channel, that would be great, about how you're feeling. That would be awesome. So the last thing we need to look at is pyramids, which is slightly different. So when we're going to look at these to figure out the area, if I take this cross-section area multiplied by the height, I would get that. Figure out this triangle by that length, I would get it, and so on. So you can actually figure out the volume of these. So it's really about just calculating the volume of those ones. Moving on to their prisms, we've looked at a cylinder. Cylinder is just pi r squared times by your height. And that's it. The only other thing is we could look at pyramids. Pyramids are an interesting concept, so I'm just going to take us there anyway. So if you take a pyramid is defined as any edge, right? It doesn't matter what your shape is, but a pyramid is all these points go up to another point. So it goes up to the middle. So every edge, so this edge, whoops, that's really bad, will go straight up to it. So it'll look a bit like that. This edge would go here. So you got to think of it as a 3D shape. That should be straight. That should not be curved, just by the way, for the record. Okay, like even this point, if it was a 3D shape, would go straight up. So every point along the edge would go straight up, right? So even these curved edges would go straight up. So this would be kind of like over here, right? So like all these points, you know, would just be going straight up to the top. Okay, now what that is this volume. Now let's just say the area of this was, again, 50 centimeters squared, and the perpendicular height of this, right to the middle, is 10 centimeters. If I went 50 by 10 centimeters, that would actually give me the volume of this weird shape. That would give me the volume of this object, right? That would give me the volume of this object. Now, saying that that is, you know, the cross section is the same all the way through, this would be 500 centimeters cubed. Now, a pyramid means that if you have a point here, all the edges will go to that point, which is this. If that's the case, you'll fit 3 of these into there. So if 3 of those will fit in there, this volume will just equal 1/3 of that one. So what does that mean? How does that help us? Well, it's quite easy. If you look at a cone, for example, a cone comes from a cylinder, right? Now, if you had this cone here and you take the height, now all the points down the bottom on the outside go to the point on top, right? So the volume of this equals pi r squared times by the height. But because it's a cylinder, we know that it takes 1/3 of that. So it's going to be 1/3 of pi r squared of the actual cylinder times the height. So it's 1/3 of it. So it takes 1/3, with the height being from the middle all the way to the top. Similarly, I like that word, if you've got a like square base pyramid, well, what you'll find, if it's a square base pyramid, if this is a square based prism, now it's not a cube because it's a square based prism, it means the base is square, but it doesn't necessarily mean this is the same length. And let's just say the height of this is, let's just say it's 10, and let's give a height of 20. This is a similar question I was just doing in the Year 9 exam, the Alpha 1. So this would be 20 centimeters, just say it's 20. Now the volume of this would be a cross section, right, which would be 100. 100 by 20 would be 2,000 cubic units. Now I'm calling it cubic units because I didn't define if it's centimeters or whatever. But if you had a pyramid, a square-based pyramid, and the word being, when I see the word pyramid, I think 1/3, unless I see the word cone. I mean, the word cone, I think of 1/3 of a cylinder. It's just a special type of pyramid. But this is a square-based pyramid. So with this one, the way you treat this is you go, oh, let's figure out what its original shape would be, which would be a square-based prism. So the word prism means that if it's a square-based prism, it's square-based and it goes, the cross-section's the same all the way through. Whereas a pyramid, it's not. Pyramid means 1/3 of them would go through. So if we talk about the word prisms, like a rectangular prism would be a rectangle on the bottom. If it was a triangular prism, you know, it would be a triangle on the bottom, right? And the cross section goes all the way through the same. Okay, so it doesn't really matter. Like that's a triangular prism because it's a triangle here and then it goes all the way through. Where if it was a triangular pyramid, it's a triangular prism turned into a pyramid where all the points go up to one point. And this would be 1/3 of the volume of that shape. So you'd figure out the volume of this and do 1/3 of it. So this would be 1/3 times 10 by 10 by 200. So it'd be 1/3 times base squared, because it's a square base, times by the height. Where this would just be base squared times by height. So that's where you, that's how we get the volume. So volume is coming from a cross section. the cross section goes all the way through it, we call it a prism, or whatever the cross section is. And then a pyramid is a third of its prism. And that's volume in a nutshell. Yeah, hopefully that helps. Remember, when you're converting between units, if you're converting just between one dimension, if you're going from centimeters to meters, you're going to divide by 100 because it's going to get smaller. If you're going from meters to centimeters, you know it's getting bigger, you're going to times it by 100. But if it's 2D, you're going to divide by 100 squared. So if I'm trying to convert area from centimeters squared to meters squared. Similarly, if meters squared to centimeters squared, I'll divide times by 100 squared. If I'm talking about 3D, I would do it cubed. Okay, so and that's pretty much it. So as long as you know your basic units, which I know you guys do, you just, you know, when you're converting between units, just go back to your basic ones and just think, am I converting a 2D unit, a 3D unit, or a 1D? If it's a 1D, just do your normal ones. If it's 2Ds, do your normal ones, but just change the power that you're converting it to. If it's 3D, again, from centimeters to meters cubed, so just say you had something that was, you know, this big, and I want to know how many meters cubed that is. Well, centimeters to meters, I know from centimeters to meters I need to divide by 100, but because I'm doing cubic units, I'm going to divide by 100 cubed. So you're just going to pull out your calculator, and you're just going to go 1, 2, 3, 4, 5. I think there is there. I can't even count. 1, 2, 3, 4, 5. Yep. Divided by 100, and you can use this button on your calculator to the power of 3 equals 0.3 cubic meters. Which doesn't sound like a lot because this looks really big, but you've got to remember what a cubic meter is. It's 100 centimeters by 100 centimeters by 100 centimeters. So if you think about that, that's 1,000,000 cubic centimeters will fit in that. So that's quite a fair bit, which isn't that much space. But it kind of is. It just depends on the scale. Like if you're talking about dirt and things like that, it's quite a fair bit of space. So that's a 1 cubic meter. So yeah, hopefully that has given you guys a bit of an insight of what we're doing. Today, tomorrow, we're just going to be working on this stuff. So I'll leave it there, but that basically gets us through all of the volume concepts, and it's just about you now getting through that. Please yelling out if you need a hand. Just quickly to recap, again, converting between units, 1D to the power of 1, 2D, we do it to the power of 2. I should have a 2 there. 3D, we just use the same conversions, but we do it to the power of 3. Don't forget, 1,000 centimeters squared, cubed, sorry, equals 1 litre. Or I can say 1 centimeter equals cubed equals 1 milliliter, because obviously it's 1,000 mils in a litre, so it's the same thing. A prism, if we talk about a triangular prism, it has a triangle, and the shape of a triangle goes all the way through. You just figure out the area of the triangle, times it by the cross section, which is the height. If we're talking about a pyramid, it's a third of its prism. So if it's a square base times its height perpendicular to the base, you'd need to do that. So if it was actually its height here, you couldn't take it because that's going from the edge to the edge. So if you knew that was 20 and this was 10, then you would actually, and this was 10, then you would actually need to do Pythag to figure out what the height was, because you would actually make that triangle, and that triangle will look like this, 20, 10. So that would be, you know, Pythag, it'd be 20 squared minus, well, that would be 5 because it's actually half of it, minus 5 squared, that one there. So that would be the height. Then you'd go the base 10 by 10 by 10 by this height times by this height, sorry, and then you have to times by a third. But you, at the moment, you'll just get this straight height going up. It needs to be perpendicular to the base, remember. A cone is exactly the same thing. It's a third of the volume of a cylinder. Again, it's a third of this is what we're talking about. And you can look at, really, with volume, we're just talking about it's the area of a cross section multiplied by its height. Hence, the very start of the lesson, volume is the area of a cross section by the height. If you understand what this is, and that the height needs to be perpendicular, which is right angles to the cross section, you've got it. Any questions, please let me know. Other